Hello, Precalculus student. This video is for chapter 1.3. In chapter 1.3 about graph of functions. In the other video, I talk about how to recognize increasing, decreasing function, average rate of change of a function, like that. So we are in this particular part where when we look at the graph, if we can see a graph, there is this points on the graph that we are interested at. So we call them zeros. Zeros. So sometimes there's one, like this line. This is a line function. It only have one zero. So zero basically is a point on the graph where it crosses the x-axis. We call them x-intercept. So in all of this part, and in this graph, you have three zeros. Unfortunately, we sometimes also call it roots. Fortunately, we call it zero, not because x is equal to zero. It's actually because y is equal to zero, and then it is on the x-axis. So when it crosses the x-axis, it's called zero. So some special features about zero is sometimes um, when a graph passes through the zero, it changes from y being negative to positive. Sometimes it changes to positive to negative, like that. So there's this special property that is very interesting that we like to find them because it helps us to graph the function. So we define zero as an x-intercept, the point a comma 0, and then this point a, or this value a, is called the zero of a function. Sometimes we would just say x equal to a is a zero. So a of course is not zero, but when you do f of a is 0. That means when you plug in this a, your output y is 0. So the point a0 is the x-intercept. Okay, so this is a definition. So zero of a function, f of x has the value when which f of x equal to 0. So to find all those 0, all you need to do is get that formula. So if you don't graph it, you only have a formula function. What you do is you get the formula and set it to 0 and solve for all the x would make this y equal to 0. So for example, I have a few examples that I want to do. The first example is I have a function that is 2x squared minus 9x plus 10. I want to find the 0. Find 0 means find those x value where y is 0. So basically you will write yourself an equation that say 0 is equal to 2x squared minus 9x plus 10. So just solving an equation, right? So now this is a quadratic equation. We cannot just isolate the terms and do it. We'd have to factor. So because a is, so we call it ax squared bx plus c. Of course, you can do quadratic formula, but factoring is a little faster. So we should try factoring first. Okay, try factor first. If factoring doesn't work, then we can always do the quadratic formula. And a lot of times when they want you to find 0 like that, they actually want you to find it by hand factor. So this is called the AC diamond method. AC diamond. So in case you want to find some more videos on how to do this, you can search for AC diamond. So the top here is AC, which is 2 times 10. This is A, and this is B, and this is C. So this is 20. B is here, you do negative 9. So A, B, C, kind of like when we do quadratic formula. And then what you do is you want to find two numbers. When they multiply, they are 20. When they add, they are negative 9. What two number? When they multiply, they are 20. So we can have 2, 10, right? They multiply 20, but when you add them, they're not 9. So it's not. Can I do negative 2, negative 10? That's also not good. But 4, 5 does, right? Because when you do negative 4 and negative 5, this would work. So let's try. Negative 4, negative 5, when you multiply them, they are 20. When you add them, they're negative 9. So I'll use this to split the 9x into two parts. So continue on. Well, actually, I'm going to write the 0 on the other side. I will say 2x squared 0 minus 4x minus 5x plus 10 equal to 0. So these two numbers are what you use to split it into 4 terms so that you can do grouping. So for factoring. So then you say 2x squared minus 5x, how do I factor is 2x, is the common factor between them. And after that, I have x factor, I have x left over. After I factor 4x by 2x, I have 2 left over. What's the common factor about 5x and 10? Of course, it's 5, so I'm going to factor negative 5 out. So this will be x minus 2. It changed to minus because when negative 5 times negative 2 is 10. Okay, so equal to 0. And you can see that the reason why I want to split it this way is so that you actually have a common factor after this. So x minus 2 is the common factor, and you factor it out. 2x minus 5 equal to 0. So x is equal to 2 and x is equal to, well, you can do this. And then you say 2x minus 5 equal to 0. I mean you split into 2 equation, right? And so x is equal to 5 over 2. I skipped some step, but you can tell. So these 2 zeros will make my function equal to 0. If I plug it in, it would make it equal to 0. So I would say the zeros are x equal to 2 and x equal to 5 over 2. So you can imagine yourself if you are to graph this function. I don't have the intention for you to graph it. You can think if I mark 2 over here, 5 over 2 is like 2.5 right here. So my graph will cut through it. So either like going from top to bottom or down to bottom. So it tells us that these are the 2 points that is on the graph. Okay, so that's the quadratic function. The second one is a radical function. Radical because I see a radical root, right, to find 0. So I would say 0 is when g of x equal to this is equal to 0, right? So I would say 0 equal to, so that means to find it, I solve 0 equal to square root of x squared minus 18. How do I get rid of the square root? I square both sides. So 0 squared is still 0. Square and square root cancel. I have x squared minus 18. Now, can I factor? So if it is factorable, I can. But 18 is not a perfect square, so I can. But I only have x squared. I don't have x term. So what you can do is move the other number on the other side and x on this side and just do square root. So x, and then now you do square root. Square root and square cancel. This would have a plus and minus whenever you do that, right? So x is equal to square root 18 and negative square root 18. But we should simplify 18. 18 is 9 times 2, right? So that would be 9 square root out is 3 root 2 and negative 3 root 2. The same for this one. So I have 2 zeros that are zeros. So I don't know what 3 root 2 is. There's 1.4. It's like about 5 or something. So you know that, oh, I have this 2 0. When I graph my square root of x squared minus 18, I would have them. So they could be like this or this. I think the graph is actually this way. If you want to, you can try graphing it in decimal. You can see that this is the exact value. The third one is find a zeros of a rational function. So rational function means it has both numerator and denominator. So again, 0 means the y equal to 0. So that means solve 0 equal to x squared minus 5 divided by x minus 1. Now, because x minus 1 is in the denominator, I need to get rid of this. And because it's x minus 1 is in the denominator, x cannot equal to 1, so the denominator cannot be 0. So I can actually multiply x minus 1 on both sides. Okay, so x minus 1 times 0 is always 0. And then I will have x squared minus 5. Okay, so x squared minus 5, well, again, I have x squared only, so I move the other one on this side, and I just do the same thing, do the square root on both sides. Remember plus and minus, okay? So equal to x, so x is equal to square root 5, negative square root 5 are zeros. Again, you can tell that they are on these two sides. Square root 5, negative square root 5. Now, when we do this, I go directly to multiply x minus 1 and cancel it. The reason is I can see that these are not factorable. There's no common factor between the two. Okay, there's no common factor between the two. But if I do this one, example 4, where in the top I have x squared minus 25 and the bottom I have x minus 5. So you have to be careful because I can if I simplify or I factor the top, I have x plus 5 and I have x minus 5, right? And then the bottom is x minus 5. So you can see that this can cancel. So I don't have to just solve the top. So if you have common factor between them, you should cancel them first. So simplify first. Before you find 0, simplify them first. Why? Later on, when we do a rational function, you notice that this particular point that is being excluded from a domain is a whole, is not a 0. So if you just do this, and just solve the top, you know, x minus 5 and cancel like that, you would end up having extra 0, which is not correct. So after you cancel it, then you say, okay, 0 is equal to x plus 5, x is equal to negative 5, and that is the answer, the only zeros. Okay. Another way to do it is you can actually say solve it, but then because x equal to 5 is not in the domain, you exclude it. That's also okay. But the faster way is just, if possible, cancel first before you solve. So that's how you find zeros of these 3 different types of function. When we do chapter 3, chapter 4 and 5, we would solve 0 for radical and also 0 for quadratic more.